Hello everyone, myself Anil Sharma from Impulse Technology Delhi. Today I will show you modeling and simulation of perovskite solar cell to calculate electrical and optical properties using SETFOS software from Exciton. Let's get started. Click on File, click on New, then rename your existing project. Right click and rename it. You can give the name perovskite-IV. You can add absorption module and drip diffusion module. Select last layer and click add layer, and you can add the number of layers. I have added 8 layers. Now you can rename your existing layer, give the name, layer name and its thickness, and you can define the constant refractive index. Similarly, rename the new layer and define its thickness. I have defined 0.5, and you can define the constant refractive index for this glass layer. Now you can select next layer, which is ITO. You can define its thickness. I have defined 120 nanometer, and now you can click on file, then click on import so that ITO refractive index can be imported. This is material database which is already inbuilt with this software. So a lot of materials are present. You can find there in the database. So I have selected ito.nk file. Click on open. Now it is added inside the project. Now you can rename the next layer. So I have defined TATM, which is whole transport layer. Now define its thickness 15 nanometer, and then click on file, click on import, and select that material. NK file is selected. Select this material as electrode and disable this. Define the work functions 5.2 here, and you can again rename the next layer. Make a distinct name of each layer. Define this layer as a perovskite semiconducting layer and define its thickness 500 nanometer, and select the file, then click on import and select perovskite materials property. The CH3NH3 PBL3, this 2017 perovskite I am opening here, that material. Now this material is added. You can find the DOI reference from there where this material is taken. Now you can select this material as a semiconducting. EATM was the electrode type. This is semiconducting. You can go to this semiconducting tab and define the HOMO value and LUMO value, and define the density of states and not in concentrations, and suppose I define 2.4 here. Now you can also enable the doping in this particular semiconducting layer. Define the concentration. So acceptor type doping, donor type doping, and optical generation efficiency you can set from 0 to 1. Suppose I set from 0.9. Now here you can define the Langevin recombination efficiency. I define 2 into 10 to the power minus 5. You can select the mobility models: constant mobility, field dependent, temperature dependent, Gaussian, disordered, and field dependent mobility model, and define the electron mobility here for electrons, and similarly for holes here. So you can define in centimeters square per second. These are trap density, mobile anions. So you can enable the ion charge transport by selecting this mobile anions and cations. You can define cation as a static mobilities and anion as a constant mobilities. Define the density here 5 into e to the power 17, and density for cations in this column. You can select the unit from this section. Per centimeter cube. Now go to the next layer and rename it. You can define C60 fullerene and select as an electrode layer. Now it is an electrode ground, and you can define its work functions It is ohmic type. Work function which is 4.1. Now you can import the file, refractive index, click on import. And import C60 NK refractive index from the database. So I have selected C60 NK file and click on open. Now the file is imported. You can rename the next layer and define as a silver AG. So AG is defined here. Now import the file. Click on import. Then select AG.NK and then again rename the next layer and give air layer. And the value is constant for air NK, so you can see 1 0. Now go to this absorption tab where you can define the sweep the absorption wavelength and import the illumination sun spectrum. Air mass 0, air mass 1.5. You can import and enable the coupling, charge coupling. So charge coupling to enable the charge carriers electron hole pairs. Now go to drift diffusion tab and you can see mode is steady state calculations. You can define transient also. Apply the voltage biasing. DC voltage wise, by default 10 voltage there. You can apply according to your need. So suppose I apply the bias of 0.5 volt DC volt. And you can enable the ion charge transport by selecting on mobile ions. Then add sweep functions and click on voltage. I defined from minus 0.4, minus 0.2, 0, 0.2, 0.4, 0.6, 0.8, 0.9, 0.9. So you can define more points to make your smooth graph. You can enable this to visualize your layer structure properly. So whatever layer you have drawn, you can visualize here. These are energy levels. Now you can click on run button to start the simulation. Now simulation got started. It will take few minutes only. Within 1 minute simulation will be finished. You can click on result window, then click on display key figure. And these are the VOC, JSC, fill factor, maximum power density automatically calculated. Now click on current so that you can plot IV curve. Now this is IV curve. You can find power conversion efficiency, power density profile. Similarly, electrical profile like Venn diagram, HOMO-LUMO and energy reference Fermi level. Charge density, electric field, optical generation efficiency, hole current and hole density, recombination, and spectral analysis, absorptance, layer specific absorptance, C60 absorptance and TATM glass layer. All these things you can plot. So reflectance, transmittance, absorptance for P analysis can be plotted easily. So these are different graphs where you can plot. So it is completely graphical user based software.